Hello class, welcome to Geometry Lesson 12-2, which is all about conditional probability. By the end of this lesson, you should be able to find the probability of an event given that another event has occurred. Okay, so yesterday we kind of focused on independent events, things that didn't influence each other. Now we're going to look at situations where the first one influences the second one, or a combo influences the rest. So, example 1, understand conditional probability. So we have a student committee is being formed to decide how after-school activities will be funded. The committee members are selected at random from current club members. The frequency table shows the current club membership data. What is the probability that a member of the art club selected at random is a junior? Okay, so if we want to know the probability that a member of the art club is a junior, first we have to look, okay, well, how many juniors are in art club? If we look, there are 16 juniors in the art club. And then how many members in the art club? There's a total of 58. So then if I reduce that, I have 8 over 29. So that is my probability that a member of the art club selected at random is a junior. Okay, so since we talked about the art club, that means that that is my total population, right? I'm only looking at the art club. That's why it's out of 58 total people. And then I want to know what's the likelihood that it was a junior. So I put the number for like what I want a junior, so it's 16 total. Okay, now why don't you go ahead and solve this one? I'll give you a little clue. The last problem we did would look like this. Okay, oh, the last problem we did would look like this. Okay, so that's just the way conditional probability is written. So the probability of picking a junior given the art club. So in this case, what is the probability that a member of the drama club is a sophomore? Good luck. Hopefully for this problem, you saw, okay, we're looking at just the drama club. That means we have a total of 17 people. And if we're looking for a sophomore, there are only 3 of them in that club that are sophomores. Okay, so question 1B, I'm going to talk through this one. What is the probability that a sophomore is a member of the drama club? Probability of drama given a sophomore. And is it the same as the probability of picking a sophomore given the drama club? Okay, so we want to look at those two probabilities. So we already know that the probability of selecting a sophomore from the drama club is 3 out of 17. Now let's figure out what's the probability of, if we look at the number of kids in drama out of the sophomores. What is the probability? So hopefully you've caught on to the trend. Whatever's listed first is the top number of your fraction. So we're looking, actually I'm going to start with the last one because the last one tells you your total sample size, right? So I'm going to look and say, hey, I have 36 sophomores to choose from. And then if I'm looking for sophomores that are also in the drama club, that would be 3. So if I simplify that, it becomes 1/12. Are those two probabilities the same? No. One's 3 out of 17 and one's 1 out of 12. So you can see that the order that it's written, little details, but they matter, right? They change the outcome of the situation due to the conditional probability. Okay, example 2, use the test for independence. So the table below shows the vehicles in a parking garage one afternoon. A vehicle in the garage will be selected at random. Let B represent the vehicle as black and V represent the vehicle as a van. Are the events B and V independent or dependent? So if we look, there are a couple different ways you can solve this. First, let's look at how many vehicles are black. We have a total 13 vehicles that are black. And for vans, we have a total of 3. And if you look, those 3 vans are black. So if we said that we want to know, are these independent or dependent? If I picked a van, doesn't that also mean I picked a black car, right? Like if I just think about that logically, not even like looking at the math down at the bottom. If I pick a van, I automatically pick a black vehicle. Therefore, these two things are not independent, right? They overlap. But if we want to mathematically prove that these things are independent, the way you would do that is first you check to see the probability of picking a black vehicle is not 0. It's not. It's 13 out of the total 22 vehicles. And the probability of a van and black is 3 out of 22. So the way that you can test conditional probability is you do the probability of the two things happening together. So in this case, that's 3 over 22, over the probability of, in this case, picking a black vehicle, which was 13 over 22. If I do 3 over 22 divided by 13 over 22, remember this division can change to multiplication, and you flip the second fraction over. Hopefully you remember doing that at the end of algebra last year. And then if I multiply, those 22s would cancel. I'd be left with 3 over 13. And since 3 over 13 does not match the probability of just picking a van, that's 3 out of 22, that means that they are not independent. If they were independent, both of them would have the same probabilities of happening. Okay, another way you could do it is you could say, okay, since the probability of picking a van is 3 over 22, and the probability of picking a black and a van is also 3 out of 22, 3 over 22 divided by 3 over 22 equals 1. And if that equals 1, that indicates that there's that overlap and they are related. They're dependent events. So it's 2 different ways. If you're still a little unsure about this, that's okay. Maybe pause the video, read through it, come see me, ask questions, talk to your friends. They can help you. And if they can't help you, again, I'm here. Okay, so question 2. Why don't you go ahead and try to solve this one. Let R represent selecting a red vehicle and C represent selecting a car. Are the events R and C independent or dependent? Explain. Good luck. All right, hopefully for this problem, you said they are dependent. Mathematically, one way I can do this is find the probability of it being a red car. There are 7 options out of the 22. The probability of it being a car and being red is 5 options out of 22. And then if I do the conditional formula where I do the probability of it being a car and red, so 5 over 22, over the probability of it being red, that's 7 over 22. If I simplify that, I get 5/7. And if it is independent, that number should equal the probability of it just being a car. So the probability of it being a car is we have 11 out of 22 options. So unfortunately, 5/7 does not equal 11/22. Therefore, since they do not equal each other, it is dependent. All right, example 3, apply the conditional probability formula. A band's marketing agent conducted a survey to determine how many high school fans the band has. What is the probability that a surveyed student plans to attend the band's concert and is a fan of the group? So the probability to attend, I'm just going to call that A, and then being a fan can be F. So the percentage of students that plan to attend are 70, or 0.7. The cool thing about the conditional probability formula is, especially when you have percents like this, you can just multiply. So the percent of students that plan to attend times the percent of students that are fans is 0.8. So out of the 70% of people that want to attend, 80% of those are fans of the band. So overall, how many are both? You would say 0.7 times 0.8, which is 0.56, or 56% of students would plan to attend and also be fans of the band. Okay, so why don't you take that idea and solve this problem? What is the probability that a surveyed student plans to attend but is not a fan of the group? Good luck. Hopefully you said of the 70% that plan to attend, 20% are not actually fans. The way I got that was I know 80% are fans, therefore the other 20 are not fans. So I would say 0.7 times 0.2, which is 0.14, or 14%. All right, example 4, this is the last example. So a marketer is looking at mobile phone statistics to help plan an online advertising campaign. She wants to find which product is most likely to be purchased after a related search. Okay, so if we look at this problem, we have product W, 46% search for it, and of the 46%, 16% purchase, okay? And you have similar statistics for X, Y, and Z. So finding the probability a mobile phone customer buys, given that they performed a related search, the way that you solve that is you do the probability that they will search and buy divided by the probability that they searched. Okay, so in this table, what I'm going to do is I'm going to convert these percentages to decimals. And so for W, I take the number of people that performed the search and buy, so 0.16, and I'd say divide that by the percent that just searched, so 0.46. When I divide it, I end up with 34.8%, or 0.348. And if I do that same thing for X, Y, and Z, which I feel like you guys are pretty confident with doing that, I can figure out which one has the highest probability of being purchased given that a related search was performed. Okay, so this is legitimately what is done in the real world. Like, this is an actual thing. You guys frequently ask me, how am I going to use this in real life? This gets used all the time with marketing. Like, you guys are, like, the stuff you search gets used by people in marketing to figure out how to better sell their products. So if we look at these numbers, you can see X has the highest percentage. It's 43.75. The rest of them are in the 30%. So product X is probably a good choice for the online advertising campaign. Now, you guys get to apply that same principle here. The marketer also has data from desktop computers. Which product is most likely to be purchased after related search? Go ahead and solve this. Tell me what product should the person buy. Good luck. All right. Hopefully you did a similar thing to what I did, and you ended up with these 4 numbers and decided, okay, product K has the highest percentage. So that would be the most likely to be purchased after a related search. And here is your concept summary for this lesson. If you have any questions, please do not hesitate to ask. I'm more than happy to assist you. Have a great day.